Hello class, my name is Professor Zalucci and I'll be explaining to you PWM. Now PWM stands for Pulse Width Modulation. Now PWM can be expressed as a periodic function such as this. Now, let's say it's 5 volts and we'll use 1 second to make life easy. Now, this is on, the pulse will be on, and this is the pulse off. Now let's say it's on for 0.6, and let's say it's on for 0.4. Off for 0.4, my bad. Now, the duty cycle would be expressed as 0.6 over 1 times 100, which would equal 60, and it would be 60%. 60% is a duty cycle. Now, let's go with this. Let's go with 2 seconds here. The amount it will be turned on is 0.4, and the amount it's turned off will be 1.6. Now the duty cycle would be 0.4 over 2 times 100, which would give you 20%. Duty cycle of this periodic function, of this PWM, 20%. Now, the direct current, the higher the duty cycle, the higher direct current is. Direct current around here would be around here, and direct current for this would be around here. For example, we will use this, and it will be 2.5, 50% duty cycle. And we'll use 1 second. So 0.5, 0.5. 1 second, 50% duty cycle. Now direct current, well, it would be 5 volts, so the direct current would be 2.5. For the direct current, the area over here has to equal the area over here. That's all direct current is saying this and this right here. The DC current of pulse modulation will feed into robots. Now, when the duty cycle is high, the DC current will be high. Therefore, the robot will move faster. The motor, my bad. On the other hand, if the DC current is slow and the duty cycle is slow, then the motor will move slower. So by changing the duty cycle of PWM, we can change the speed of a robot. This can be done by processing or computer-wise. This is an H bridge. An H bridge is an electronic that enables a voltage to be applied across a load in either direction. These circuits are used in robotics and other applications to allow motors to run towards and backwards. When switches S1 and S4 are closed, a positive voltage will be applied. When S3 and S2 are closed, this voltage will be reversed from S1 and S4. Now, all this is saying these switches close, so it will look something like this. And then let's say S2 and 3, it will look like this. So the current is moving through here. Current I is moving through here. Now, There's a little chart you can remember. If S1, S2, S3, and S4.
I can do this.
Now, if they're open, I would represent 1 as open and 0 as not open. A little bit of binary code. 1, 0, 0, 1. This would mean it's going to the right. I'm expressing right as R. It would be 0, 1, 1. It's going to the left, which means switch 2 and 3 are open. It's going to the left. Now, free roaming would be 0, 0, 0, 0. None of them are open. Brace is 0, 1, 0, 1, and then 1, 0, 1, 0. S3 and S4 cannot be open, or S1 and S2. They cannot be open together. That is the rule of H-bridge. Thank you very much. This is a speech from Professor Lucien, and I hope you had a great time learning with me. Thank you very much.